Have you ever wondered how your smartphone knows the difference between a friend's name and their actual phone number when you're saving a new contact? Behind the scenes, your phone relies on something called a variable. You can think of a variable as a digital label or a sticky note that the computer attaches to a specific piece of information so it can remember it later. To create one of these labels in Python, we use the equal sign. But in coding, the equal sign isn't about math, it's an instruction. We're telling the computer to assign the value 14 to the label age. Without these labels, the computer would store information without any way for us to find it again. By using variables, we can recall or update that data at any time just by typing out the name on the label. These variables act as the essential memory building blocks for any program, turning human logic into organized digital storage. You can't just write whatever you want on these labels, though. Python has a strict rulebook for how you name your variables. Rule 1. A variable name must always start with a letter or an underscore. You can never start a label with a number. Rule 2. Spaces are not allowed. If you want to use multiple words, like first name, you use an underscore to connect them. And be careful with your capitalization, because Python treats uppercase and lowercase letters as completely different labels. Rule 3. Certain words are off limits. Words like true, if, or for are reserved by the system to help it understand the structure of your program, so you can't use them as your own labels. Following these rules is critical because it prevents the computer from getting confused between your custom data labels and the core commands it uses to run your code.
Pacing slows down. Now that we know how to write the label on the outside of the box, let's look at the specific flavor of data we're putting inside. Python sorts information into specific categories called data types. Every piece of data you use belongs to one of these branches. First, we have the integer, or int type. This is for whole numbers without any fractional parts, like the number 42. Next is the floating point, or float type. This category handles numbers that contain decimals, like 3.1415. Then we have strings, or the str type. These are sequences of text. The rule here is that strings must be wrapped in quotation marks, so the computer knows it's reading text and not a command. Finally, there's the boolean, or bool type. Think of this like a simple light switch. It only has two states, true or false. Sometimes you might need to forcefully change a piece of data from one flavor to another using built-in functions. This allows you to do things like take a number with a decimal and chop it down into a whole integer. Assigning the right data type is essential. A computer can easily add two integers together, but it can't perform math on two text strings. As your programs get bigger, you might find yourself wanting to use the same label name for different things in different sections of your code. To keep these labels from clashing, Python uses boundaries called scope. The outer boundary shown here is the global scope. A global variable acts like a public announcement. It's accessible everywhere throughout your entire program. But inside that, we have the local scope. A local variable is restricted entirely to the specific function where it was created. It's hidden away from the rest of the code. Think of it like a one-way mirror. A local zone can look out and see global variables, but the global level cannot look inside a local zone to see what's happening. Managing these zones prevents you from accidentally overwriting important data, keeping your short-term local memory separate from your program's main memory. So why do we call these labels variables in the first place? It's because they are designed to be changed or mutated. Imagine a game where your score is 10. When you collect a coin, your score becomes 15. The label simply detaches from the number 10 and reattaches to the number 15. Python is incredibly flexible with this. A label doesn't just have to stay the same flavor. You can start with a whole number and then reassign that same label to a line of text later on, and Python will handle it seamlessly. To recap, variables are labels for your data. They follow strict naming rules, hold specific flavors like numbers or text, and live within localized or global zones. Now that you know the basics, here's a question for you. If you were writing a program to store your exact shoe size, which data type would you use? An integer or a float? Let me know in the comments.